Hello there, Orlando Solis with Advanced Quantitative Reasoning, and we're talking again about regression. And right here on this one, we're looking at time value money. We're trying to go ahead and put together an exponential regression because if we look at the data right here, it doesn't grow at a constant rate. It gets a little bit different. So if you take the difference between 500 and 32.5, that's 32.5 is a difference. And then if you do the same thing, you can notice that 567 minus 532 is a little bit more than the constant of 32.5. So it's not a constant, so that's not linear. So it's definitely going to be exponential or something like that. There's other ways to tell. Let me just go ahead and go through that real quick. If you take 532.5, well, actually, I'm going to take divided by 32.5, divided by 500. Okay, I'm going to go ahead and get that, and as we got 1.065. And then if you take 567.11 divided by 532.5, it should be the same. So I'm going to just go out on a limb, and yes, it is the same. So that's the constant rate. So that's the constant rate of change. So this is actually growing at a rate of 6.5% each year. So it's 6.5% interest. That's actually quite large for any bank. So if anyone really knows, let's see. Let's go ahead and go back to our data. So this represents the years. So we have year 1, 2, 3, or 4, and then we have, well, actually I forgot year 0, and it's there. It's just that it's kind of covered up. Yeah, there it is. Year 0, and then you have 500, and then all the growth after that. So we're going to go ahead and take a look at this graph first. And I'm going to show you a couple of things. First, I'm going to put years, and then we're going to go ahead and put the amount right here. And as you can see, it looks like it should be a linear graph. So we're going to go ahead and take a look at this and you make the assumption that it is linear. We're going to go to the linear regression, show linear. There it is. And as you can see, these kind of points don't really fit. But if we take a look at the regression, so right here, to get to the regression, we have to go to option 4, residuals, and then go to residual plot. We can see a definite pattern, and since there's a pattern, that means that the linear model is not an appropriate model for this data. So according to this, since it has that curve right here, this is more than likely exponential. So this is when we're analyzing data straight out. So I'm going to take off the residual plot, hide the residual plot, and then I'm also going to go ahead and turn on, go back to analyze, and we're going to turn off the regression, hide linear. So now we're going to go with analyze regression, and this time we're going to go to exponential. So this is option 8. And as you can see right here, and remember it's 500 times 1.065. So that's our base of change. So exponentially, this is going to increase by 6.5%. It's 6.5% growth. That's actually 1 plus 0.065 and on the original thing. So if we take a look at the residual, we have one of two things that are going to come up. Either it's going to be perfect and everything's going to appear on that line, or it's going to be like this, which shows a random pattern. So it's a random pattern. So this is going to be a really good estimation of our linear model, or actually exponential model. So that's where you go ahead and do the regression on this. Of course, you can go ahead and do the regression like this also. Now that we've gone ahead and analyzed the graph, I'm going to go ahead and do the regression. I'm going to do an exponential regression, which is option A here on the regular calculator. We're going to take the X list, which is years, and then the amount for our Y. And of course, our R, which is our correlation coefficient, is 1. That means that the data is almost perfect, that it's really, really compact together. So it's really, really good. A really well compact information. Just remember, R does not say that this is an exponential function. It only states that the data is very well packed together. That's all it states. And of course, our function is y equal to, and I'm writing it here just so you can see it. A is 500, so we follow this right here, which is A times B to the x power. So this right here is going to appear like this, 500, and this is going to be 1.065, close parentheses, and that's going to be to the power of x. And that's how you would go ahead and take a look at this graph. So that's how you do regressions and for exponential data. This is how you analyze if the data is an appropriate model. If you had it at first glance, it looked like it was linear. But then when we did the analysis, looking at the residuals, first we did a regression and then we did the residual. We could have copied the regression from there just to say. But if you want the correlation coefficient, you have to do it this way. So that's about it for that. If you have any questions, just leave them in the comments. I'll go ahead and answer any questions that you may have.